Sitting here, respected teachers and my dear audiences, very good day to you all. This is MD Abrar Jahin, and today I'm gonna present my undergrad thesis titled Supply Chain Backorder Prediction Using Interpretable Hybrid Quantum Classical Neural Network, supervised by Dr. MD Saiful Islam sir. Backorder means the unfulfilled customer orders, but in real-world datasets, the number of backorder samples is much lower than those of non-backorder samples. Classical machine learning models suffer from datasets complexity and dimensionality, leading to suboptimal performance. However, variational quantum models reduce the overfitting issues, learn more quickly, or attain better test accuracy. The objectives of my thesis are to create a hybrid quantum classical neural network and compare it against the existing state-of-the-art models, to develop effective data preprocessing methods to address class imbalance issues, and to enhance the model's interpretability using explainable AI techniques. Here I tried to show the state-of-the-art benchmarking on the same dataset that I used. The research gaps lie in the implementation of hybrid quantum classical techniques using short and imbalanced datasets, models suffering from computational complexity and overfitting issues, and not being robust enough. Here I illustrated the whole methodological framework that starts from identifying the data sources, then collecting public dataset from Kaggle, data splitting and robust preprocessing techniques, followed by the architecture of my proposed Q-amplify-net model. We preprocessed the data using 7 different preprocessing techniques and selected the best one based on the evaluation on ROC-AUC score, that is, receiver operating characteristics area under the curve. This is the logic behind my model's nomenclature. Here goes the Q-amplify-net's architecture, and these are the technological frameworks that I used in my research. Among all the other classification metrics reported in my research, F1 score, accuracy, and area under the curve are the main classification metrics used for evaluation in my study. Here, I showed the performance comparisons of 18 different models implemented in my thesis, where my proposed model Q-amplify-net showed superior performance than the other models. This figure illustrates that Q-amplify-net shows lower false negative and false positive rates than the other models, which is the most crucial factor in backorder prediction problems. To validate my claims and model superiority over the other models, I performed 10-fold cross-validated paired t-test taking alpha value of 5%. And in case of all models, we found p-values to be less than 5%, ultimately rejecting the null hypothesis. In this bar plot generated by Lime for a single instance, we can see the feature importance influencing Q-amplify-net's prediction. This plot, generated by Lime as well, complements and supports the previous plot. Here, the shape decision plot shows that feature 0 contributes the most and feature 2 contributes the least to Q-amplify-net model's prediction. Q-amplify-net achieved the highest F1 score for predicting not backorder and backorder samples, outperforming all the other models, and also exhibited the highest AUC-ROC score of 79.85%. Our novel hybrid QCNN model designed explicitly for backorder prediction problems in supply chain domain. Using SHAP and Lime, we understood how the model arrived at its predictions. The limitations lie in the fact that angle encoding and basis encoding await further exploration. Due to constraints in current quantum hardware, we could only use 2 qubits. There lies potential for increased depth size. Q-amplify-net can also be applied in demand forecasting or inventory optimization problems. Here goes all the references that I used for this presentation, and my thesis led to successful publication in Nature Scientific Reports. Thank you for having patience. If you have got any questions on your mind, you are most welcome.